Good afternoon, everybody. My name is Sarah Hassoun Al Sayed. I'm a PhD candidate at University of Cambridge, and during this short video, I will be introducing myself, my work that I have been doing, particularly over the past year. I will be talking about, uh, according to the best of my understanding, what are the regulatory procedure one have to go through while planning a preclinical study here in the UK. What are the most commonly used preclinical model in context of the orthopedic research, and a reflection of how I find my overall experience of being a member of the Orthopedic Research Society. I'm a veterinary surgeon by training. My undergraduate degree was from Alexandria University, Egypt. I also got my master's degree from there. My PhD experience was at University of Cambridge. I'm also a proud member of the beautiful Newnham College in Cambridge University. I have been awarded the title of Associate Fellow of Higher Education Academy for the UK last October 2022, and I am privileged to be the secretary of the preclinical model section of the Orthopaedic Research Society from 2022 to 2024. So I started my journey here in the beautiful city of Alexandria at the north of Egypt over the Mediterranean Sea, where I got my bachelor degree in 2012, my master's degree in 2015, and I worked as an assistant lecturer of veterinary surgery at Alexandria University from 2013 to 2017. At 2018, I decided to fly north and landed in another beautiful city at the east of England, which is the city of Cambridge, where I started my PhD journey in 2018. I have recently submitted my PhD thesis in December of 2022, and now I'm preparing for my vivo exam. So fingers crossed. So the work I have been doing, particularly within the last year, the main project I was responsible for within the past year was related to my PhD work, which is designing and characterizing a 3D printed bone graft substitute biomaterial. The preclinical model of choice during the study was a rabbit long bone critical size bone defect, which we chose the rabbit radius, and it was a 15 millimeter bone defect where the 3D printable bone substitute biomaterial were implanted there. Another study I was involved at, but it wasn't part of my PhD. This study was related to bone infection, which is quite similar yet different from my PhD work. This one is also a rabbit radius defect. It's a smaller defect, it's the 5 millimeter defect, but the purpose of it is to evaluate the performance of antibiotic-loaded 3D printed scaffold in treating orthopedic device-related infection. So this one was infection-related study rather than bone healing-related study in the first animal model we spoken about a minute ago. This particular two studies has been done as a collaboration between our lab at the University of Cambridge, the Surgical Discovery Center, led by Professor Matthew Allen, the AO Research Institute in Davos, led by Dr. Stephen Zeiter, and the University of Rochester Awad Lab, led by Dr. Hani Awad. Besides these two preclinical studies, another thing I would call a hobby of mine is designing and 3D printing a patient-specific surgical guide and implants, which was also kind of included in my PhD work, the aim of the 3D printable bone graft substitute to be designed as a patient-specific implants. This one is different. It was a case study I worked with in collaboration with the clinical research team at the Queen's Veterinary School Hospital in Cambridge, about designing a 3D printable patient-specific guide for repairing humeral intracondylar fissure repair in dog case studies. Besides that, there is another study, not necessarily within the past year, but it was done in 2021. This one, it was a rat study to evaluate the biocompatibility of the 3D printed scaffolds that I used later for bone defects, for the rabbit bone defect model. The rat study was a very simple model. It's subcutaneous implantation model following the ISO guidelines to evaluate and put a score of the material tissue interaction there. The results from the previously mentioned studies were published in these three conferences, which is the Orthopaedic Research Society annual meeting of last year at Tampa, Florida, the World Congress of Orthopedic Research in the beautiful city of Edinburgh of September of last year, and late September, early October was also the 21st ISVOT Congress in the beautiful city of Nice in the south of France. I would say the most commonly used preclinical model at the University of Cambridge in context of orthopedic research are the rodents model and the sheep model. There are well-equipped facilities, animal facilities and housing for the rodents and sheep at the University of Cambridge. The rodent model, rat, mice, and nude mice, particularly used for oncology studies, and Professor Matthew Allen has a long track record of working in osteosarcoma mice model, particularly nude mice model. There is a lot of study going on about musculoskeletal and neurobiology using rodent models. There is some bone tissue engineering and articular cartilage tissue engineering study in rats as well in the University of Cambridge using a rat model. And there is some osteoarthritis-oriented studies in rat model. In the sheep model, there is arthroplasty, testing different joint replacement devices and implants in sheep, bone fixation devices, and osteoarthritis study, spine, and some musculoskeletal tissue engineering oriented study. When we're talking about small ruminants, you will not see many goat studies in the United Kingdom. It's mostly sheep, to be more specific, a Welsh mountain sheep, which is used as a small ruminant orthopedic preclinical model. Regulatory barriers. It's a very important point to be put in consideration while working in the UK with animals in context of research. The United Kingdom rules are very strict about pursuing research on animal. It's governed by the Home Office, which is a governing body, under the ASPA, or Animal Scientific Procedure Act 1986. In the United Kingdom, they take animal research very seriously. There are two types of licenses one have to secure before starting any animal work. Every individual in the team member have to have a personal license. Even as a vet, you're not qualified to work in research or using research animal without having a personal license authorized by the Home Office first. This personal license will have the pieces you are allowed to work with, as well as the category of procedures you are allowed to perform under this license. For instance, people who have category A are only allowed for husbandry, injection, and non-invasive procedure. While if you want to do surgery in animals, you have to get a category C license. And each one of these categories involve a training course, a written exam, as well as a practical assessment exam. And every project has to have a project license. It's one license for the entire project, usually held by the principal investigator, who himself or herself or themselves have to set a course to prepare them to hold a project license. And it is a very time-intensive and require a lot of planning in advance and a lot of patience. The good news is there is always somebody around to advise you what needs to be done. At the University of Cambridge, for instance, they are represented by the UBS, the University Biomedical Services team, and there is an internal animal welfare and ethics reviewing body. It's called AWERB. It's also university localized that basically kind of read your drafted project license and give you feedback on this draft before you submit it to the government body, which is the Home Office, to get approved. To give you an insight at how long that it takes, from personal experience, the project license for my PhD work took 11 months in order to get approved. From the first meeting we had with the AWERB committee until we had the license approved, it's 11 months. And the document that is our license is 70-page long document. So it's a very tedious process. The greatest challenges besides the regulation and the time-consuming licensing are everybody facing the question, which preclinical model is the most relevant to my work? Which animal I'm gonna choose, and in this animal, what type of the preclinical model. There are standards and there is published guidelines and a lot of literature, but it takes time. It takes a minute until we actually decide on which model suits best the purpose of the study. Having the textbook answer which model doesn't solve the problem. It's just the start, just the beginning. We have to balance this ideal preclinical model with the facilities, the funding, the equipment, and personnel we have in hand. Otherwise, we might end up basically biting more than we can chew. We have to think, is it wise to elect to do this study, the ideal study where I'm working right now, or it's better to collaborate or outsource or expand the network to do part of the study in another university in the United Kingdom or in Europe or in USA for better equipment and personnel and facilities that contribute towards the success of this study. And the third thing, I usually find it challenging in the planning and in the presenting the work as well. Like the sample size calculation, how many animals to include in each of your study groups. It's like the chicken or the egg riddle. In order to calculate the N or the sample size accurately, in theory, we have to run a pilot study before even thinking about the main study. But given the regulatory restriction, funding restriction, timing restrictions, not everybody has the privilege or the resources to run a pilot study first. So we usually rely on literature reading, previous experience, as well as there is very useful online tools about sample size calculation, but it's never as accurate as running a pilot study first, which, as I said, is not always feasible for everybody. Finally, thank you so much for listening to my short video, and I would like to say being a member of the Orthopaedic Research Society is actually a very enriching experience in many ways. The most obvious one is networking. During my time in contact with Orthopaedic Research Society, I met amazing scientists, clinicians, veterinarians, and engineers. I don't think I would meet without being a member of this amazing society. As they say, I highly recommend to a friend to be a member of the ORS if you are working in the field of orthopedic. It's an amazing society. You will find a lot of collaborators, mentors, and maybe sometimes also sponsors as well. Thank you so much. Enjoy the rest of your afternoon and see you later.